Hey folks, welcome. This is 8.2. Let's do the exercises, the practice off to the right. Good news, my pen's working well now. I'm super excited about that. Tell whether the function represents exponential growth or decay. With our general template here, if our base, b, is a value that's greater than 1, it's going to be growth. And if b is, greater than 0, but less than 1, it's going to be decay. So here's growth, here's decay. So that's what we'll look at here. We're questioning the base, and here our base is 2/3, which is less than 1. It's 0.666, so that's decay. Here it's 5/4, which is 1.25, so that's greater than 1. So that value is going to grow over time, or as we go to the right. Here it's greater than 1, so that's also growth. 0.7 is less than 1, so over time the value will shrink. That's decay. 1/3 is also less than 1, so that's decay. And then here our base is 3, so that will be growth. Let's try some graphing. So here you could plug in some positive numbers perhaps. If you plug in too big a positive, it's not going to fit in the graph. Same with negative numbers, but negative will not fit on the graph here. So I plugged in 0, 1, 2, and 3, and I got 6, 3, 1.5, and 0.75. And so as I plot those, here's a picture, and this is what you should expect from decay, right? This is a decay function because my base is less than 1. Something like this. And those numbers will get closer and closer and closer to 0, but not touch it because 0 is a horizontal asymptote here. Y equals 0 is, whoop, there we are. Then, for this one, as we practiced on 7.1, when we figure out our values, let's stay right here. So in this table, I'm going to write the values for the function 4 times 1/2 to the power of x. Then that minus 2 is going to shift my graph right 2. And this minus 3 outside of the exponent is going to shift it down 3. So when I just do this portion right here, oop, let me get that out of there. There we go. When I just do this portion, when I plug in 0, I get 4, 1 is 2, 2 is 1, 3 is 0.5. Negative 1 will actually fit on here this time. So let me graph this portion. Now this is kind of like my parent function, but it's not the end function. So negative 1 is at 8, 0, 4, 1, 2, 2, 1, 3.5, 3, 0.5, and there it goes. So now let's apply the shifting. Let's take every single point that I plotted here and shift it right 2 and down 3. So here's my first point. So I'm going to move it right 2 and down 3. Here's my next point. I'm going to move it right 2 and down 3, which actually puts it on another point, which is interesting. Right 2, down 3. Right 2, down 3. Right 2, down 3. And then these points get closer and closer to 0, but now I'm moving them right 2 and then down 3. So right 2, down 3. Right 2, down 3. Guess what? Now instead of hovering just above 0, it's going to hover, because I moved it down 3, it's going to hover just above negative 3. So that reminds me that I forgot to address the domain and range. So in number 7, the domain is all real numbers. We can plug in negative numbers for x, that's fine. But the range, what's going to be output from this function, well, it'll never be a negative number. We'll never get a number less than 0 or even equal to 0 out here. So our range, or our y values, will always be greater than 0. Over here, using the blue function, the blue graph, I can plug in anything for my x value. But the output, it looks like, will never go below 3, or on 3 even. So y greater than, negative 3. It'll never get to negative 3. So the y value is always going to be above negative 3. So our range is y is greater than negative 3. So now let's try computing some exponential growth and decay, because you actually are going to see some growths on here. I know that we've been focusing on decay this unit, but let's see what happens. A tool and die business purchases a piece of equipment for $2,500. The value of the equipment depreciates at 12% every single year. So here's the first question. How much will it be worth after 5 years? So it depreciates. That means that it's losing value. So in this equation, that's not a plus or minus, pick your favorite. This is a plus or minus, pick the right one. Depreciating is going to be a minus. It's decay. So initial investment is this much. We're losing. Oops. And remember to convert this percentage to a decimal. So we're losing 12%, which is 0.12, and we're raising it to the power of 5. And when you do that, your handy-dandy calculator will tell you, or should tell you, that that equipment after 5 years is now worth $131,000, $932.98. So for part B, it's the same piece of equipment. It still depreciates 12% every year, but now we're wondering, after a total of 10 years, what's it worth? So initial investment still cost us that much when it started, and every year it still loses 12% or 0.12, but now it's going to drag on for 10 years, so now it's only worth $69,625.24. By the way, folks, in your calculators, to get up to this level, as we talked about before, you either use the power caret key, if you see that. Some calculators have this button. And so you'll have to, with the caret key, you would put that right in front of the 5 or right after the parentheses. Sometimes these buttons work differently depending on your calculator style. So you have to play with that. Maybe pick an easy power, play around with this button, and see, try to take 2 to the third, which should be 8. So sometimes the order that you push this button is kind of different. You punch in maybe this and hopefully you got 8, and then that should go in the same position. Anywho, that was a weird tangent. Okay, a company buys a building for $500,000. The value of the building grows at 2% each year. How much is the building worth in 5 years? So initial investment is this. Now, a big piece of information here, folks, that we can't overlook is that it grows at 2% every year. So that means that we're taking the value, which is 1, and then adding to it 0.02. And they are wondering about after 5 years, you would get $552,040. Same building, same growth rate. How much will it be after 10 years? So the only thing you switch now is the time, being 10. And then you get $609,497.21. Last but not least, studying your Spanish. You memorize 100 Spanish vocabulary words. You do not practice them after that day, so you forget words at a rate of 10% per day. How many words will you remember after 9 days? So our initial investment or amount is 100 words. We forget words, which means we're losing them. So we're subtracting 10% of what we have every day. You actually don't need the 0 behind that, but I put it. And after 9 days, what do we have left? When you calculate this, you get 39 words. Make sure you label it. It's not $39, it's 39 words. That's what you've got in your bank right now, your mental Spanish vocab bank. And there we are.